Nature follows rules we don't expect. Two electrons, opposite spins, not by chance. Somehow they share this behavior, always opposite. This is where physics gets interesting. Deep learning begins with one simple question. How? This is CG, your chemistry guide. What if I told you this strange behavior hides something beautiful, something Einstein once called spooky? Don't worry, no heavy math, just an idea and a reason to wonder. Physicists call this strange connection quantum entanglement. In 1935, Albert Einstein noticed it and felt deeply uncomfortable. He called it spooky action at a distance because it challenged how physics was supposed to work. Soon after, Erwin Schrödinger gave this idea a name, entanglement, and explained that some particles cannot be described separately, only as one shared system. Decades later, Richard Feynman showed why this mattered. He taught us that nature itself works this way, and that this strange connection is not optional, but fundamental. Quantum entanglement was not invented. It was discovered, questioned, named, and slowly understood. Imagine flipping two ordinary coins again and again. Sometimes both are heads, sometimes both are tails, sometimes opposite. Each coin behaves independently. Now imagine something that cannot happen in classical physics. Two coins are quantumly entangled. They are entangled in an opposite state. Every time you flip them, the relationship is fixed. If one coin shows heads, the other always shows tails. If one shows tails, the other always shows heads. Even if you separate them, one coin is tossed in India, the other is tossed in Germany. The moment you see the result in India, you instantly know the result in Germany without looking. Think about that. This is the strange power of quantum entanglement. Now replace coins with particles. Imagine two electrons created together. They are formed as a single shared system. One electron has spin up, the other has spin down. Separate them by any distance. When you measure the spin of one electron, you immediately know the spin of the other. They behave as if they are still connected. But there is no string, no signal, no communication. They are not talking to each other. This happens because the electrons were never independent. When they were created, nature did not treat them as two separate objects. Instead, they were formed as one shared system. So even when separated, the rule that governs them remains shared. This does not mean faster than light communication. It means correlation without communication. Entanglement is not a property of particles themselves. It is a property of the relationship between them. In classical physics, each object carries its own properties, and distance breaks connections. In quantum physics, entangled particles do not have independent properties. Their behavior is defined only as a pair. You don't need to understand everything today. Just remember this feeling, that nature can be stranger and more connected than our everyday experience. Let the idea sink in, because curiosity is where science truly begins. Stay curious.